got a polynomial up here on the board, and the directions are to graph it. I should probably have said, oh, I did say that. Sketch the graph, okay? And more specifically, include the y-intercept, all x-intercepts. Make sure you have the correct end behavior, and your graph needs to be positive or negative on the appropriate intervals, okay? All right, now this is a problem for you folks to try, but I recognize I gave this to you and it's not in factored form. Now, I will tell you the way we're going to factor it is by grouping. If you remember how that works, go ahead, pause the video right now, do this problem. If you don't remember how factoring by grouping works, let's work through that together. Then when we finish that, I'll have you pause the video and use the factored form to get the graph. Okay, so my key that I might want to use grouping to factor this is, I can see I've got 1, 2, 3, 4 terms. If I have 4 or more terms, and there's no useful greatest common factor. The greatest common factor here would be 1, and factoring out a 1 doesn't make anything simpler. I can't factor out any x's because there aren't any x's in that term. And I can't factor out any numbers because the coefficient here is 1 and the coefficient here is -1. So there's no greatest common factor that I can pull out of all 4 terms. So I'm going to group. I'm going to say this is the first pair, x cubed plus 5x squared, plus the second pair, -x minus 5. Now notice I said it's the first pair plus the second pair. I did not say it was the first pair minus x minus 5, because this negative sign goes with just the x. It doesn't apply to the 5, okay? So I can't put the negative sign outside of the parentheses. I've got to put it inside of the parentheses. So all I'm saying here is that the sum of these 4 terms, some of which are negative, is just the sum of the first 2 plus the second 2. And now what I'm going to do is within each pair, I'm going to see if there's anything that I can factor out. X cubed and 5x squared, that has a greatest common factor of x squared. And that's going to be multiplied by x plus 5. Okay. So that's my first pair in factored form. Plus, let's do the same thing for my second pair. Now these don't have a whole lot in common, but they are both negative. So I could factor out a -1. And if I do that, that's going to change both signs to make it an x plus 5. So I still have my first pair plus my second pair, but now they have something in common. This is what I call the leftovers. That's what was left over after I factored out the greatest common factor from each piece. The leftovers are the same. If they aren't, the factoring by grouping didn't work. Either try pairing them off a different way, or possibly you're not going to be able to factor by grouping and you'll need some other technique. But if these are the same, now I can say, oh, this and this have something in common. They have an x plus 5. So let's factor out that x plus 5. What was it being multiplied by? Well, here it was multiplied by x squared, and here it was multiplied by a -1. So notice that's x plus 5 gets multiplied by x squared. There's my first pair. X plus 5 gets multiplied by -1. There's my second pair. Nice. So we've partially factored by using some grouping. Now I want to look and see, can I factor anything further? Now this is already a linear factor. It's not going to break down anymore. This, oh, that's a difference of 2 squares. We've seen that one before. So that's going to be x plus 5 times x plus 1 times x minus 1. So this right here is our f of x in factored form. Okay. So if you hung out through this point to review the factoring, now that we've got it in factored form, pause the video and try to sketch this graph. Of course, if you paused the video before this, you've maybe fast forwarded, come back, pay attention as we actually look at the graph and do the rest of this problem. All right, I've got our polynomial written up here, and I just copied the factored form here. Now, we were asked to graph this, including all of our intercepts. So we want our y-intercept, Now, on the y-axis, I know that x is 0. So this is going to be a point whose x value is 0. And then the y value will just be my function evaluated at 0. I think it's easiest to plug into the non-factored form, because when I plug in 0, those three terms go away, and we just get a -5. Notice, you could have gotten that by plugging into the factored form, because if I plug in 0, this becomes 5 times 1 times -1. Either way, I get 0, -5. Beautiful. Okay. Now for our x-intercepts, we need to find our zeros, but that's why we did this factoring. Because now I can say if this function is equal to 0, one of these factors is going to be 0. So my zeros, which are just the x values of the x-intercepts, will be -5, -1, and 1. I basically mentally just said what it would make x plus 5 equal 0, and then I could see I'd have to subtract that 5 over. And I did that for all three factors. Now that means that the x-intercepts are the points -5, 0, -1, 0, and 1, 0. Okay, excellent. Now I've got some options for how I proceed from here. I could use the number line, I could use the end behavior combined with the multiplicity, or I could do a combination of both, which would be a little bit redundant, but that's going to help me catch any careless mistakes. I think I'm going to do that. So I'm going to start with the end behavior. So the lead term, well, that's just x cubed. Easiest to spot that from the version we had before we factored it. So now I can say that means that as x goes to infinity, f of x is going to go to infinity, because all power functions go to infinity when you plug in something big and positive, unless you've multiplied by a negative coefficient, which we haven't. So when I'm ready to graph, I know we're going to end up going off to infinity somewhere over there. And as x goes to -infinity, f of x is going to go to -infinity, because it's going to do the same thing that x cubed does. So my graph is going to end up down here. Now, let's just create a number line. I'm going to mark off my zeros. So -5, -1, and 1. I'm just going to pick some test numbers to check the sign of things. There's a little bit of redundancy built in, because I sort of know already that to the left of -5, we should get something negative. And I know between -1 and 1, we should get something negative, because I've already done a little bit of that work, but I'm just going to double check. Okay. So let's see. I'm going to record the signs of each factor, x plus 5, x plus 1, x minus 1, and then the overall sign of f. So a test number that's smaller than -5, I could use -6. -6 plus 5 will be negative. -6 plus 1 will be negative. -6 minus 1 will be negative. F should be negative. Excellent. That confirms what we got from looking at our end behavior. Between -5 and -1, I think I'm just going to plug in -2. So -2 plus 5 would be positive. -2 plus 1 would still be negative. And -2 minus 1 would be negative. A positive times two negatives would give me something positive. Between -1 and 1, let's just plug in 0. Pretty sure we should get something negative. Let's just confirm. 0 plus 5 is positive, 0 plus 1 is positive, 0 minus 1 is negative. Two positives and a negative do, in fact, give me something negative. To the right of 1, I can plug in 2. 2 plus 5 is positive, 2 plus 1 is positive, 2 minus 1 is positive, 3 positives gives me a positive. That's confirming what I knew ahead of time. Okay. So we start out negative. At -5, 0, we've got to change to be positive. At -1, we're going to change to be negative. We're going to come down and hit this point. We're going to come back up through here. And I'm just going to adjust this, it's not going to actually become less steep, because that would give me almost another turning point. So the end behavior is still that we're going up and right. I'm just aligning it with where I was after drawing my previous points. Quick check. Looks like at each of the intercepts we crossed the x-axis. That's correct, because each one of them had a multiplicity of 1, which was odd, so each of those x-intercepts should actually be a crossing point. Now, I purposely made it so that 0, -5 was not the low point on my graph. I don't know where the low point is. I was just trying not to assume. If you made that the low point, totally fine, because that's not something that we're trying to figure out this semester. Next semester, you will have calculus. Calculus will tell you how to find the highs and the lows. This just tells us there's a high point somewhere between -5 and 1. I don't know where it is. It doesn't have to be exactly halfway in between. And I don't know how high it is. I know there's a minimum somewhere between -1 and 1. I don't know that it's exactly halfway in between. It could be at 0, but it could be to the left, it could be to the right, and I don't know how low down it is. Okay, so that's okay. I just want to point out that while we've got an awful lot of information and a lot that we can be confident about here, we're not perfect in our curve sketching yet. There's still a lot that we don't know, and that's totally fine. But I think it's important to acknowledge that we don't know that, and that there's still something to learn about, hey, how do I figure out where the high point is and how high up it is? That's an interesting question, and I'm telling you, algebra doesn't cut it for that. We're gonna need to use calculus for that. So that's something that you'll have to wait on until next semester.